Hello friends, myself Professor Dattu Patel from LJ Institute of Engineering and Technology. Today we learn series solution about ordinary point by a power series method. Let us start with one example. Find series solution of x square plus 1 y double s plus xy s minus xy equal to 0 about x0. First, whatever the coefficient which is multiplied with y double s, that is indicated by p0 of x equal to x square plus 1, which is not equal to 0 at x equal to 0. Then we can say that x0 is an ordinary point. Now, given differential equation is x square plus 1 y double s plus xy s minus xy equal to 0. That is our equation number 1. Then expand it. Then we get x square y double s plus y double s plus xy s minus xy equal to 0. That is our equation number 1. Let y equal to summation k equal to 0 to infinite ak x raised to k is series solution of given equation. Now expand this equation, then a0 plus a1x plus a2x square plus a3x cube and so on. That is our equation number 2. Now differentiate y with respect to s twice, then we get differentiate y with respect to x twice, then we get y dash equal to summation k equal to 1 to infinite ak k x raised to k minus 1. Again differentiate summation k equal to 2 to infinite ak k minus 1 x raised to k minus 2. Now substitute y double dash y dash y in equation number 1. Substitute y double dash y dash y in equation number 1 and we get x square k equal to infinite ak k minus 1 x raised to k minus 2 plus summation k equal to infinite ak k minus 1 x raised to k minus 2 plus x summation k equal to 1 to infinite ak k x raised to k minus 1 minus x summation k equal to 0 to infinite ak x raised to k equal to 0. Now this x square goes inside the summation, this x which is also goes inside the summation, and this x which is also goes the inside the summation. Then in multiplication form, x square into x raised to k plus k minus 2, then power will be added. Then we can get summation k equal to infinite k minus 1 x raised to k plus summation k equal to infinite k minus 1 x raised to k minus 2. This x square will be goes inside the summation. Then we can get x equal to summation k equal to 1 to infinite k x raised to k minus summation k equal to 0 to infinite x raised to k plus 1. Now, in first term, power of x is k, second term power of x is k minus 2, third term power of x is k, and fourth term power of x is k plus 2. Now, to make highest powers of x, to make the highest power of x with the help of replace the value of k. Then in first term we replace k as a k plus 1. In second term we replace k as a k plus 3. In third term we replace k as a k plus 1. Then we get each and every term has same power of x. Then first term summation limit is k equal to 1 to infinite k plus 1 into k x raised to k plus 1. In second term summation limit will be changed k equal to minus 1 to infinite k plus 3 k plus 2 into x raised to k plus 1. Next term summation limit k equal to 0 to infinite k plus 1 x raised to k plus 1 minus summation k equal to 0 to infinite x raised to k plus 1 equal to 0. Now each and every term has same power of x, which is x raised to k plus 1. Now, but first term has summation index is minus 1, second term has is minus 1, third term has 0, fourth term has which is also 0. Then to make same summation index, if we goes to 0 side, summation index which is zeros, if summation index which is negative, here which is positive, according to the line segment, we goes to 0 side of the summation index. If summation index which is negative, then expand it up to 0. And if summation index is positive value, then we goes to directly put 0. So in this term, first term is summation index is 1, means positive, then we put directly as a 0, and second term which is summation index is minus 1, then that is negative, then it is expand up to 0. Clear? Then in first term summation k equal to 0 to infinite k plus 1 k k plus 1, k x raised to k plus 1. In second term, put the values of k equal to minus 1. Then for a2, 2 into 1 x raised to 0 plus summation k equal to 0 to infinite ak plus 3 k plus 3 k plus 2 x raised to k plus 1 plus summation k equal to 0 to infinite ak plus 1 k plus 1 x raised to k plus 1 minus summation k equal to 0 to infinite ak x raised to k equal to 0. Now equate the coefficients of various powers of x with 0. Then we get first one is 2a2 equal to 0, then a2 equal to 0. Remaining terms ak plus 1 k plus 1 k plus ak plus 3 k plus 3 k plus 2 plus ak plus 1 k plus 1 minus ak equal to 0. Now in first and third term ak plus 1 and k plus 1 which is common, then we get ak plus 1 k plus 1 which is common. Remaining term in first term k, remaining term which is 1 plus ak plus 3 k plus 3 k plus 2 minus ak equal to 0. Now multiply this term, then ak plus 1 k plus 1 whole square plus ak plus 3 k plus 3 k plus 2 minus ak equal to 0. Now do the subject as ak plus 3. Then ak plus 3 equal to ak goes that side, then we get ak minus ak plus 1 k plus 1 whole square and denominator portion which is k plus 3 k plus 2 where k greater than equal to 0. This equation which is indicated by recurrence relation. Now put the values of k. Sorry, here x raised to k plus 1. Put the values of k equal to 0, 1, 2, 3, etc. in recurrence relation. First, put the value of k equal to 0. Then we get a3. A0 minus a1 divided by 3 into 2, which is a0 minus a1 divided by 6. Then put the values of k equal to 1 plus 3, that is a4. Then a1 minus a2 divided by 4 into 3, but value of A2 is 0. Then we get A1 divided by 12. Then similarly k equal to 2. Then we get A5. Here A2 minus A3. 2 plus 1, 3. 3 square. 9 divided by 2 plus 3. 5. 2 plus 2. 4. Then minus 9 by 20 into A3. Then minus 9 by 20. Put the value of A3, which is A0 minus A1 divided by 6. 3 2s are 6, 3 3s are 9. Minus goes inside. Then A1 minus A0 divided by 40 into 3, which is A5, and so on. Now, substitute A3, A4, A5, A6 and so on in equation number 2, which is y equal to A0 plus A1x plus A2x square plus A3x cube and so on. A0 which is same as, A1 which is same as, value of A2 is 0, value of A3 which is A0 minus A1 divided by 6 into x cube, value of A4 which is A1 divided by 12 into x raised to 4, plus value of A5 which is 3 by 40, A1 minus A0 into x raised to 5 and so on. Now, in this term, first here and here, A0 common, then first one is 1 plus x cubed by 6 minus 3 by 40 x raised to 5 plus and so, plus A1 common, then x minus x cubed by 6 plus x raised to 4 by 12 plus 3 by 40 x raised to 5 and so on. That is equation number A, where A0 and A1 are arbitrary constants. This is the required solution of given differential equations. Similarly, you can solve another examples. First one is 1 minus x square y double dash minus 2xy dash plus 2y equal to 0 about x equal to 0. Another one example is 1 plus x square y double dash plus xy dash minus 9y equal to 0 about x equal to 0. As a tutorial, if you have any doubts, then contact me. Thank you so much.